Let's take a closer look at two more very important types of load carriers: plastic totes and trays. What you're seeing on this slide is a broad variety of load carriers used across different types of storage and picking systems. At first glance, they might all look like simple plastic boxes, but in practice there's a surprising amount of engineering and standardization behind these carriers. These totes serve a wide range of functions. Some are used for manual picking, others for fully automated systems. Some are stackable, others are designed to nest inside each other when empty to save space. You'll also notice different shapes, some with straight sides, others slightly conical, which makes them easier to separate when stacked. Some are designed to collapse or fold flat, which is useful for return logistics. Let's start with the most common type, the standardized Euro-sized tote, typically in gray or blue plastic. These are the workhorses of automated small parts warehouses. Their outer dimensions are standardized, for instance 600 by 400 millimeters, or slightly more than that, like 610 by 410 millimeters. So they fit perfectly into racking systems, shuttles and conveyors. But if you look closely, you'll see a lot of variation in height, lid type, and sidewall design. In highly automated systems, it's critical that these containers interact flawlessly with conveyor belts, sorters, and robot arms. That's why their outer dimensions are often standardized, especially in terms of length and width, while their internal design can vary depending on the specific use case. There are also bins with open fronts, like the bright yellow one. These are typically used in static shelving systems or flow racks, where fast access is more important than stackability. They are common in manual picking environments or workstations for kitting. Toward the bottom left, we see foldable totes. When these aren't needed, they collapse flat. That's an enormous advantage in reverse logistics, especially for systems that involve a lot of empty container returns, like in supplier loops. And then we see trays, thin, flat load carriers, often used when the item itself can't be handled reliably on a conveyor. A tray provides a standardized base, so the automation system only has to recognize and move the tray, not the individual item on top of it. Think of soft packaging, unstable parts, or even small bags that would otherwise get stuck. All of these carriers are selected carefully, depending on the warehouse layout, the type of goods, and the degree of automation. You may have several different totes in the system, but as a general rule, you try keep that number as low as possible. And lastly, let's not forget that color also plays a role. Blue, gray and red are common and widespread. Color coding can also be used internally, for example, to identify quality status, picking priority, or area of use. Now that we've seen the wide variety of totes and trays in action, let's look a bit deeper into the specific characteristics that define them. This table breaks down the most important features we consider when selecting the right load carrier for a given warehouse environment. Let's go through these categories one by one, and I'll explain what they mean in practice. We start with format. Most totes are based on standardized footprints and typically fractions of a Euro pallet. That means 600 by 400 millimeters or 400 by 300, and so on. This modular approach ensures compatibility across all equipment, racking, conveyors, lifts, and shuttle systems. But of course, there are also non-standard formats, especially for specialized industries or older systems. Next is the lid. Some containers have an attached lid that folds closed, useful for secure storage and stacking. Others use a separate lid or no lid at all. Whether or not you need a lid depends on factors like dust protection, tamper resistance, or whether the totes will be transported outside your facility. Shape is another key factor. Straight-walled totes are ideal for automation because they maximize usable space and ensure consistent positioning on conveyors. But if you need to save space on return transport, conical shapes are better. They allow the totes to nest inside each other when empty. Material comes next. Most bins are made of polypropylene, or PP for short, a durable, lightweight and cost-effective plastic. In some cases, expanded polypropylene, EPP, is used for shock absorption, for instance in electronics, or healthcare logistics, or simply for reasons of temperature insulation. You'll also want to consider whether the material is new or recycled. Recycled materials are increasingly popular for cost reasons. Companies will say for sustainability reasons, but it's normally cost reasons. But they may have slightly different mechanical properties or surface finishes. Totes from recycled material typically come in gray color, so you can't choose any color you like. Also, they are less resistant to sunlight and low temperature environments. Stackable containers are those you can safely pile on top of each other when full. A must for space-saving vertical storage. You see this in cube storage systems like AutoStore. Nestable containers, on the other hand, are designed to sit inside each other when empty, reducing their footprint by 60 to 70%. That's huge for return logistics. Then we have foldable totes. These go one step further and collapse completely flat. They cost more initially, but over the life cycle, they can save a lot of space and money, especially in closed-loop systems. Because, or the joints they need to be able to collapse, they are not perfect for environments with high hygiene requirement, like transportation of unpackaged food. Front wall design is important too. An open front allows easy picking access without lifting the bin out of the rack. The famous Schiefer bin is an example of a warehouse bin with an open front. A closed front provides more stability and protection, especially in automated storage. Some totes are dividable, meaning they can be customized with inlays or separators. This allows you to store multiple different SKUs in the same tote, thereby saving storage space. This can be a good idea in systems with a high number of small, slow-moving parts. It can complicate some processes in automated systems. However, so it's not a magic trick that you should pull without careful consideration. We'll talk about this later in greater detail, either in this course or in the follow-up course. Conveyability means the tote is optimized for automated movement. For example, flat bottoms, reinforced edges, and defined center of gravity behavior. Some are also designed for low noise conveying. An ergonomic improvement especially appreciated in large facilities where hundreds of totes are moving constantly. Low noise means less stress and a better working environment. Next is ESD protection, which is essential when handling sensitive electronic parts. These containers are made with special materials that discharge static electricity safely, protecting the contents from damage. Food-safe bins comply with hygiene and safety regulations for use in the food industry. That includes both material selection and the ability to clean them thoroughly, often with high-pressure washing. In terms of identification, we have several options. Some totes are equipped with RFID tags for automated tracking. Others use simple barcodes or labels. Then we have the environment in which the tote is used. Some are designed for in-house use only, which typically means lighter duty and lower cost. Others need to handle both internal and external transport, which often means rougher handling, weather exposure, and stricter durability requirements. Deep freeze compatibility is another specialty feature, important in pharmaceutical or food logistics. These bins must maintain their shape and strength even at sub-zero temperatures without becoming brittle or cracking. The bottom of the tote may be flat or textured. A flat bottom is necessary for smooth travel on conveyors or in ASRS systems. A textured bottom can add grip and reduce slippage, especially when totes are manually handled. And finally, we look at handles. Some totes have open grip handles molded into the side. Others feature foldable handles that reduce interference during stacking or automation. And some may have no handles at all, especially when not intended for frequent manual handling. As you can see, the variation is large. The selection of the load carrier can influence many other design choices in the warehouse engineering process.